Here we go. This is going to be the last video we're going to do for section 10.2. We're going to look at section 3 called rationalizing the denominator. The purpose, go ahead and take that down. I have written there in the red. Rationalizing the denominator means that we want to eliminate the square root in the denominator. You're going to do this a lot next year in geometry. Kind of a rule right here, you never ever want to be left with the square root in the bottom, okay, which is the denominator. So we're going to show you a technique of how we can eliminate that square root in the denominator. Now you can see we have circle. We're going to do 1, 2, 3, and 6, and some of this kind of ties into the quotient property, which was the last video. If we look at number 1, the square root is only in the bottom, but this 3, you can't simplify that any further. It's not a perfect square, and there's no perfect square that goes into it. So what we're going to do is, if we can't eliminate, or if we can't simplify the bottom square root, I'm going to multiply the top and bottom by that same square root. I'm going to multiply the top by root 3, and I'm going to multiply the bottom by root 3. Now what this winds up doing, this, I'm just going to get 2 root 3 in the top. I can't multiply them to give me 6 because the 3 is in the square root and the 2 is not. The bottom, here I can multiply these together because both those 3's are in the square root. So if I use the product property there, that gives me the square root of 9. Now the whole point of that is this is a perfect square. So square root of 9 is 3, so our answer here is just, try to squeeze this in, 2 root 3 over 3. And just like that, I have 3 in the denominator. I don't have a square root in the denominator at all. Okay, let's make this a little bit bigger. Alright, let's look at 2. Alright, kind of same concept here, just like number 1. This square root is 6. There's no perfect square that goes into it, and 6 is not a perfect square. So I'm going to do the same thing I did for number 1. I'm going to multiply the top and bottom by this square root of 6. So again, this 5 times root 6, I'm not going to get 30 for that. I'm not going to get square root of 30 because the 5 is not in the square root and the 6 is. So that just stays as 5 root 6. Again, here I can multiply these. 6 times 6 is the square root of 36. And then square root of 36 is 6. So our answer for 2, which is 5 root 6 over 6. You can kind of see this pattern here. I have no problem if you guys multiply this. Root 6 times root 6 just winds up giving you 6. Alright, so now we move the square root to the top, and we've rationalized. Okay, and we look at 3. 3 looks like a lot like the quotient properties. Well, we're first going to ask ourselves, remember we did the quotient properties, 4/5, does this fraction simplify at all? And it doesn't. So since it doesn't, we're going to use the quotient property. So I could rewrite this as the square root of 4 over the square root of 5. Let's see if this helps us out. Well, the square root of 4, that helps us out. That's a perfect square. Square root of 4 is 2. Unfortunately, this square root of 5, we can't simplify that. So we have 2 over root 5. But remember, we want to rationalize the denominator. We want to get rid of the root 5 in the bottom and move it to the top. So I'm going to multiply top and bottom by the square root of 5. So now we're rationalizing it. So the top, we're going to get 2 root 5. And then I'm going to skip this step. This root 5 times root 5 is the square root of 25, which just gives us 5. That we can't simplify any further. So we have 2 root 5 over 5. Okay, let's just do one more. Let's do number 6. Okay, number 6, same thing again. I have this 18 over 10. Now, unlike the last one, this can simplify. 18 over 10, that would simplify to, let's see here, 2 goes into each. It would simplify to 9/5. And then I use the quotient property. So this is just like saying the square root of 9 over the square root of 5. Okay, this square root of 9, that's a friendly number there. It's a perfect square. Square root of 9 is 3. Same thing, this root 5, you can't simplify it, so I leave it as root 5. But we're not done yet because we have to rationalize the denominator. I want to get rid of that square root of 5 in the bottom, move it to the top. So I multiply top and bottom by root 5. So the top, I'm just going to get this, 3 root 5. And the bottom, this is going to give me 5. Right? Square root of 25 is 5. So that's it. That's our answer, 3 root 5 over 5. All right, so main thing with this, whenever you have a fraction, you have square roots, you can never ever be left with the square root in the denominator.